Welcome, everybody. My name is Tova Devorin. I am the Senior Product Marketing Manager here at SafeBreach. And welcome to today's webinar, From Chaos to Clarity, How SafeBreach Parsers Elevate Detection Engineering at Scale. I'll be your moderator, and I'm pleased to introduce you to our speakers today. That includes Jonathan Tillman, our Senior Technical Account Manager. Say hey, Jonathan. And Shaka Faviv, our Product Manager. We're all very excited about this webinar, so let's get this show on the road. But before I do, 2 simple housekeeping items. One, just know that this webinar will be available on demand after the live session. Life happens, you have to leave in the middle, you want to go catch lunch, you weren't able to make it, no worries, you'll get it in your email after the session. And second, we'd love to hear from you for today's presentation. If you have any questions at any time, please type them in the questions box. We will try to get to as many questions as possible at the end of the presentation. And if we don't specifically get to your question, we would be happy to follow up with you one-on-one after this webinar. So without further ado, let's get started. Let's talk about parsers and detection engineering.
Yeah, great. Thank you, Tova. So hello, everyone. So we will start we will cover a few things that relate to detection engineering, and of course, parsers will be part of it. I want to start with the basic, as what is detection engineering, and before that, why detection engineering? Like as every product manager, I'm heading first to the problem, what detection engineering trying to solve. And we know that, of course, that most of you already aware that as an organization, we are creating multiple kind of detections that end up into, like, in every organization that are facing this issue of countless alerts and that causing an alert fatigue. And detection engineering is about ensuring that the right ones, like the right detections that we want to talk about, are getting the right attention, and also that they are validated as we wish in terms of our organization preferences. So in simple terms, detection engineering is basically a discipline of designing, testing, and improving how your security control detect threats. So it's not just writing queries and rules. It's building a structured process that's ensure those detections are accurate and most relevant and in a more continuous and continuous way of refinement and evolving. The goal of detection engineering is, first of all, of course, to detect a real attacker behavior, but second of all, avoiding overwhelmed analysts with false positives that cause, as I said, an alert fatigues. And we know that according to multiple resources that shows that implementation of detection engineering can deliver 2 to 5 times ROI within a few years, reducing, as you know, like reducing incident impact and boosting SOC efficiency and improving the overall coverage for visibilities. And essentially, this one is shifting security operation from being a reactive into proactive, this is the movement of today's security. And we all know that detection engineering is how we turn raw telemetry and logs into a meaningful signals. But as adversaries evolves, detection engineering has to evolve just as fast. And on that case, where automation, testing, and validation comes in, and that's exactly what SafeBreach enables, which we will explore really shortly. So this is detection engineering really in a simple terms. Let's try to get it from a different angle through analogy. Tova, can you switch slide? Yeah, so we want to take it from a different angle, as I said, from analogy of a net to catch an invasive or harmful fish. We have to play here about the word fish. So let's imagine our sea is our network. Our network is a sea, and it's a large and complex environment full of regular benign fish, but also some harmful one. And you, as a detection engineering, you are the net maker. You are creating a net, but not just any net. You're creating a net that can catch only one specific or a few type of fish that might harm your ecosystem. And that's what detection engineering is all about. Each net you design is a detection rule. It's meant to catch a specific kind of malicious behavior, and not only any movement in the water, or if we want to go with the analogy all the way, any splash in the water. But the more precisely you design it, the more effective your detect threats, and without having too much noise and drowning into too much alert fatigues. And when we are talking about adapting the nets and evolving detection, so that's a crucial part, because as new fish or threats are appearing, you refine and build new nets. Just like you would do with your detections, and refining your detections or creating a new one. And that is all about detection engineering. The whole point is to be able to defend yourself and to be able to detect any malicious activity to keep your ecosystem or your fish farm or anything that basically represent your environment into something that it's safer. And having this, after we understand like what is detection engineering in a more simple terms, there is a complete detection engineering life cycle behind it, and that's what JT is going to add to it right now.
Thanks, Shahaf. So what does that look like in practice, right? You're building a net, how hard could it be? If there were just one kind of fish that you had to find, maybe not so bad, but our reality is that there are many, many different kinds of threats, and they can also change. And so when a team gets into serious detection engineering efforts, there's some complexity. And so this is the software development lifecycle that's adopted to a detection engineering lifecycle. And so companies adopt this kind of process to be able to manage that complexity, to be able to scale, and also to be able to optimize workflows by integrating technology into the process wherever possible. So we're going to briefly discuss this process, and then after that, I'll talk a little bit more about how our technology then fits into this process. And so to start off, I like to look at the center where you just see the two sections of detection creation and detection maintenance. And so for the first part, requirements gathering, it's basically you have an inbox, you might have multiple different teams saying, hey, can we detect this? Should we detect this? You're going to have inputs from a threat intel platform, from security research published that makes the news, things like that. And you might need to prioritize if you can't make all the detections that week. And you also might need to deduplicate and kind of be aware of your existing catalog as well. Then when we get over into the design and the development, that gets more into, do we even have the logs we need? What kind of logic are we going to use? Do we know ahead of time any exceptions we might want to make so that they're not too noisy and we don't get false positives? And then the testing and deployment is where you actually make sure the detection fires, and running a SafeBreach simulation that does the malicious activity is one good way to make sure that detection triggers. And then now we're going to get over into the second part, then the detection and maintenance. And this is the part where our technology contributes the most, but I'm also going to talk about ways it does also contribute in the other light blue areas. And so the monitoring and continuous testing is about making sure that all the alerts you have already spent the time making don't just stop alerting when it's important, during when they're supposed to be detecting the current active threat. And so we've had some of our customers, when they get to a couple hundred detections, spend so much time trying to make sure that what they have is still working, that they were struggling to find time to make new detections. And so, being able to have a technology that will, on a daily basis, do the activity and then let you know if any of the detections failed is a huge time saving. And we'll get into some more details about that. So that's the cycle, and it's a repeatable, scalable business process. So now we're going to look at the next slide and talk a little bit about how our technology fits into this cycle in ways that some of our customers are already doing. So this first part is about writing a new detection, getting started with it in your initial validation. If you're a detection engineer and you want to make a detection, you might not have any log samples. You might not know have anything to start with for how that looks like in your environment. And so running the SafeBreach simulation is a good way to get that activity. And then you can create your logic off of it, and then run that simulation again. Make sure that the detection triggers, and then you can also check other areas. So that initial development is usually done on like one simulator, but there might be many locations with different logins, different applications. So now you want to run that initially across many simulators in your environment to see if there are edge cases where you need to account for or different criteria. And so the technology assist can be part of that whole section. And then when you get into when you have a published production detection, you want to make sure that it doesn't break without having to manually confirm it every day or every week. And so the ability of having just automatically scheduled scenarios to be able to run and do that on a daily basis. Honestly, as a quick tip, our customers started off running it maybe twice a month or weekly, but they found out that if it's much easier to investigate what went wrong that caused the alert to fail if you're only looking at a 24-hour window compared to a week. So they started running them daily. And of course, this can scale to hundreds or thousands of however many detections you want to have. And then the last part is kind of the highest maturity level of using API and integrations to set up a detection as code pipeline and also some automation at the end. So what the detection as code pipeline looks like is there's an API call to create the initial attack in SafeBreach, and then it will run the attack, and then it will get all the integration correlation data, and it'll basically just give the detection engineer a pass-fail on whether that alert triggered. And the benefit there is the detection engineer doesn't need to be trained on SafeBreach. They don't need to wait for a human to be in the loop that knows how to use SafeBreach. They click a button in their playbook, and they get a pass-fail. And then another part of the validation is at the end of every day or every run, when there are 2 or 3 alerts that were identified as not working, some customers have also set up automation to create tickets to go to the proper app owner or team that could resolve that logging deficiency and get that alert back in shape again. So those are the many ways that the technology can be part of the process and also integrate seamlessly with the other tools that you're using in this process. Thank you.
Great stuff, JT. Yeah, so that's an awesome thing that we can do with SafeBreach detection engineering, but in terms of what enables us, this is our parsers. So parsers makes all of this possible. So parsers are like translators that take unstructured log data that we are gathering from all of our security tools that we are integrating with, and turn it into a structured and meaningful event that SafeBreach can understand eventually. All of that is turned into a measurement that contributes to your overall security posture that reflects how defend are you in terms of your security control and your testing that you are executing. So the structure of this security events and these parsers is allowing us to determine if a simulation was prevented, if it was detected, logged, or alerted, and by which security control. And until now, we had parsers before. That's for sure, because that's the way of translating security control logs into something that SafeBreach understand. But the experience was a bit challenging. Customer couldn't understand how to make it on their own, and you had to understand like some logic that occurs behind the scenes. And we understand that we need to create a new parser wizard that basically takes you step by step through all the process of creating a parser, that visually shows you how to create the matching criteria and how to map fields and how to determine what is the status that will contribute to our simulation result, and all of that without any code needed. And the goal here is to make it effortless for any organization to tailor SafeBreach to their unique log formats, to their unique requirements and their evolving environments. And that's what parsers are all about. Tova, can you switch slide? Thank you. And so we understand what is parser, so let's try to understand what is the flow of the parsers. So as a SafeBreach customer, you are running simulations to test your security. One of the main use cases are testing your security controls and how they are and how effective they are. Whether it's an EDR, whether it's a firewall, DLP, SIEM, you name it. And running those simulations, you are expecting to see those security control enrichment into our simulation results. So we are gathering during the tests logs that are relevant to the simulation that you executed. We are gathering a few types of log with different formats, and the parsers, this is where the parsers come into action, are translating those logs into something meaningful called security event, which is something that eventually will contribute to our simulation result status. And these security events and the parsers are built out of two main components. The first one is field mapping. So we are mapping keys from the logs that we are receiving from the security controls into fields that relevant to SafeBreach to understand the context of the log. And second of all, it's the status definition. So we need to determine what is the action that was done by in that specific log that contributes to our overall simulation result. And after we have this blocked or not blocked, like a binary result that SafeBreach know if they succeeded with operating this attack, and the enrichment from the security control are both determining our simulation result final status, which contributes to your test results overall security posture, and in general, your overall security posture, as we can see on the right side, that reflects how your defenses are doing in terms of your workload that you run according to your test that you are running. And that's what Parsers is all about. If you just summarize the bottom line, it's translation between the security controls that we have integrate with and our security posture and the implementation within the results within SafeBreach. And this is about what is the parser. Let's understand what are the benefits that we can get from the parsers, as JT is experiencing it on a daily basis with customers. So JT, over to you.
Absolutely. So yeah, we heard all of the things and options you can do, but let's talk about some situations in your day-to-day workflow where you would benefit from doing parsing. The first one is defining and classifying and customizing how you want your detections to be processed and categorized. And doing it this way with the parser in our app means you can just teach our app how to handle and interpret the detections the way they are, instead of needing to maybe go back and edit all your detections and insert different tags or ways that different tools ingesting them can recognize. This is a way to just, however the detections already are today, can be processed by our app. And then another situation is an integration without an integration, right? So what does that mean? So basically, you can get the benefits of having a full-on direct integration, but you wouldn't need that, because you can send the logs go to the SIM, and then our app ingest them to the SIM. They might not be in a recognizable standardized format, but it's as you'll see, it's easy to make a parser to know how to interpret those logs from a homegrown app, or from sometimes you're evaluating a technology and you don't necessarily want to go through the cycles to set up the direct integration. You can get the benefits of that prevented and detected and just the traffic you want, and do that with parsing. You can also enhance your reporting and your analytics when you're, especially important when you're talking about scale and analyzing large numbers of results. So by mapping different fields, you can put different values in the results. So you might have names or team names or something like that for your detections, or group or different subgroups of them. You could find a field and map that to them. And or sometimes the logs themselves from different places, you want to populate as much data as that are in the logs into those fields, and so that's going to help. And when you're looking at one individual result, but also when you get into dashboards and filtering and drilling down and into different patterns. And you can also, if you like, there are some situations where you might want to customize your status logic to some definitions that you have in your current risk management framework. And it's perfectly fine to do that as well. Doing it at the parsing does that as far upstream as possible, so that you don't have to do that translation like later downstream in your own reporting of SafeBreach stuff. You can just do it right in the app. And then last but not least, operationally, environments change, apps get updated, log forwarders have an update, or for some reason the log format changes. Instead of needing to go and find the app owner and try to negotiate a different structure for the logs that might then interfere with some other tool that is ingesting those logs, no need to do all that. Just simply go in and adjust our parsing and teach our app how to ingest them however they are, and then you will be in good shape for when any of those things come up in your workflow.
Yeah, awesome. Awesome stuff, JT. I think we can go to a demo.
Hey.
Basically, see how parsers are operates. I will share just for a second. Okay. Is my screen visible?
Yeah.
Great. Okay, so we want to see parsers in action. Like, what is the use case of parsers? One of the use cases of parsers. So we can go into a simulation that was specifically here logged. And this is important. We want to notice that this simulation was not blocked by security control, but had logged event in our security events. So we identify it was not blocked, but we get any kind of security event. Specifically here, for this use case, we looking at an event that received from Microsoft Defender for Endpoint that was classified as logged. But if we will observe a bit about the log itself, we can understand, just for the case, of course, that it has a policy ID. Policy ID, let's say I'm a detection engineering in an organization, and I want to claim that any log that has a policy ID should be classified as a detection, because that's a log that was triggered by any kind of my policies or detection rules. So our goal is to turn this log into something, to a report log that will be eventually causing the simulation to be a detection. So as I said before, we had parsers. The experience was challenging. As I said, you had to go here and you had to choose for a specific parser, and you got this this parser on the left side and the log on the right side, and you had to understand how the parser would be behind the scene, which is challenging to do it by yourself. And it requires more of CS from our CS team to assist customer with that, and also our development team. So we understand, as I said, that we need to bring a better experience and take you a step by step through the parser's creation. So we now added this parser button that parse this specific log. So for example, I want to choose this one. And I'm here at the new parsers wizard. We can see just for a quick look, we have this log that we want to parse on the right side. We have all of the steps that we need to do in order to complete the parser, to save it. And yeah, let's start and we'll dive into each one of the steps. And I will explain everything throughout the demo. So first of all, we need to choose if we want to create a new one or we want to edit an existing one. So we can choose either way, whether it's SafeBreach parser or custom parsers. For that specific use case, as I said, we want to create a parser for Microsoft Defender for Endpoint for detections. And specifically, I recommend you to give an actual description that represent what the parser is doing. Let's say you in 6 months, you want to understand what you created. So that's a great example of how you can help you to understand what is the parser is for. So for example, here we want to create a parser that finds policy ID and define it as detection. Okay, finds, of course, and defines. Once we have everything here, we have this green indication that we can proceed. So we can go next. So we have this matching condition. Matching condition is the conditions that are saying that the condition I'm setting here are the one that are measuring against the log, and if the log is matching the matching conditions, so the parser will be parsing, will parse them. So we can define up to 5. We can create and or and adding conditions here, and do and or between them. But just for adding a specific field, I just want to have a quick look about how we are, what are those fields. So those are the keys that we are extracting live from the log on the right side. As you can see, for example, we are also referring to a hierarchy manner into the logs. For example, system.provider, it's that specific field. So for example, I want to create a condition that once system provider equals, so we have all these operators and the value is inserted automatically, but I can change it whenever I want. So I want to say that if system provider equals Microsoft Defender for Endpoint, of course, we are talking about parsing Microsoft Defender for Endpoint logs. And also I want to add this the policy ID, right? So we want to understand that this log contains a policy ID. So we want to say that if policy ID exists, once I have everything in place, I have this test button that allows me to verify what I'm doing and and if I'm doing in the right side, it's check it against the actual log that we are working on. So for example, if I'm testing it, so we can see the matching criteria are correct. Let's try to change something here and test it again, and it will throw an error that something is wrong, and I need to verify that. Without testing it, I will not be able to proceed. Of course, we want to give you the most probability of ending and saving this parser. So this is why this is built in that way. And now we are heading to the step number 3, which is the field mapping. So as I said, we have the SafeBreach fields. Those are the mandatory fields, the fields that we are need from the logs to understand the context of the log. Those will be mapped into the security event table. And we have the extracted field. Those are the fields like we saw in the last step that are representing the keys, as we said. So for example, if I want to say that event time, which is a required field, I want to set it to be assigned with the end time that I have right here. So that will represent me the timestamp. Also, I can do it from vendor. Also, I can type here and I can see that system.vendor, which is Microsoft in that case. And for product, we can go with the provider. But there are many things that you can do it as well. For example, source. Source I don't have in this particular log, but I can do a default value that will represent me what is the source. So for example, it's a production environment. So I can use it just write production. And as you can see, I got an indication of creating a new value, a default value. So I can just assign it and I get this blue indication that is a default value. And that's also something that's possible. Also, for example, in action, as we saw before, the action was logged. Now we want to change it. It's a detection, right? So we can do like nice things here. So this one is a conditional field, allows me to set up a phrase that if it's true, then we can set up a default value or a value that will be inserted according to our preferences. So for example, here we want to say that if there is a policy ID, if it exists, so I can call it detect. What happened? Detect. Okay, so I can insert detect, but also one nice thing that I can add here is also using parameters. So I can refer using parameters to other values within the log that we are arriving. So for example, we are receiving. So for example, if I'm saying that a detection is pointing on a specific policy ID, I can insert this policy ID value into the result, the value that I'm inserted into action. So this is the syntax. Of course, it's all documented in our documentation. You don't need to memorize it. I ensure it to you. And once we have everything here, we can test it, of course, to verify everything. Once we do that, we can see that the event time was inserted, the detected, and the ID that we had in the policy ID is inserted also as a value. We have the vendor and the product and our default value for source production. Once we do all that, we can proceed to the next step. And this is the last step that is really important to the creation of the parser. So basically, you are deciding here what will be the status of the log that we are receiving. So you can do many conditions for each one of them. Each one can contains up to 5 conditions. And we have, if I will test it right now, it will be a logged event because the default is log only. You can set the default and we can change it according to our preferences. But if I will test it just now, I can see that I get this status indication, the blue one that indicates that it is a log. But we don't want to be a log. We want to make it a report, right? So we can create multiple conditions here, but the most important one is the policy ID. As we said, we can do exist, but if we want to be a more specific one, so we can say, for example, use regex, or for example, let's try to do like, for example, 2, 4, 5, 6, and 5, 6, 7, 8. And I will test it. And as I can see, if I'm testing it, the log is still log only. But if I add the 1, 2, 3, 4 and test it, I can see that it is matched to the criteria that I defined for the report, and the log, we got this indication that it is a report really. And that indicates us that we completed our mission, and we can proceed to the next step. Of course, we got this indication that allows us to understand that we are in the right track. So here is the last step, completely the last one. This is the parsing order. So each parser has priority. The logs that we are receiving are going through this list as the first one in the list will be the first one the log meets. And the first one that the log is matching to its criteria will be parsed by the parser that is matched by that criteria will parse the log. So it's really important to determine what you want that the priority will be. For that example, I will put that in the top priority. Okay, so we can see here that the parser reordered successfully. And once we have all in place, we can go ahead and save everything. Once we save that, we will be taken to the simulation result page. And we can see here that it's still logged. Once we do refresh, it's basically fetching events again from the security control. In 1 second, we will see that the logs change because it meets again the parsers, but now there is the new parser that we created. And now, as we can see, the status is changed, and also all the parameters that we inserted into the log in the parser, we can see here that it's now reported by Microsoft Defender for Endpoint, and we can see that the status of the simulation was changed. That's what was all about, and we can say, hey, this was a detection, a successful detection. Yeah, and that's pretty much about what is parsers, what is a use case of parsers can look like. Yeah, and I think now we can go into questions. Right?
Sounds good. Thank you, Shahab. That was a very informative and thorough demo. Really appreciate both of you being on today. Let's dive into some questions. JT, let's hand it over to you.
Okay, so one question is about what happens when there's four kinds of logs that are different. Is that one parser or 4 parsers? Okay, so this is like an EDR might have 4 types of logs, or maybe your firewalls might have traffic logs, threat logs, wildfire logs, etc. And those log formats would be different. Do we want to try to have one parser with the matching criteria and status calculation that can work for them all, or is it better to just make 4 parsers? And for that, I recommend 1 parser per log. That's going to be easier to create, easier to test, easier to manage. And I want to reemphasize the pro tip that Shahaf said about using the description in the parser to write what the detection was needed for, because yourself or a coworker 6 months from now might come in and have a question. What is this parser? What did it do? Do we still need it? And so instead of having to go and look at the logic, you can just read and you can know if your environment changed, if you need to change or keep it. And so making 1 parser for each different kind of log, and then just have the priority, any custom parser, just have the priority above the standard built-in one, and you're set. You don't have to manage it any more than that. And there's, having many parsers, there's no kind of impact on performance or correlation time or anything. That'll just rocket through them all. So good stuff.
Yeah, that's fair. Good. Do we have time? I think we have time for one more question.
One more. What are some other real examples? So I see an opportunity a lot of times with the SIM. So a SIM like Splunk will have a standardized format. It's called CIM in this case. And so logs, when they're ingested in the SIM, can either be in that format or not. If they're in that format, our built-in parsers will take care of them, no problem. But oftentimes it's not possible or just wasn't done. And so in that case, it's now easy to just teach our app to read those logs how they are. I talked about sometimes there's some informational alerts that you don't want to be showing as like a detect status, and you would rather just have those as log because that's not exactly what you're looking for. And then really sometimes there's several small optimizations like Shahaf was showing with the different values and parameters. And one of those small changes might not make a difference, but in aggregate, all of those little small optimizations, they make a big difference when you're talking about dealing with the data at scale and importing the data to other reporting tools. And so now that it's easy to do those little small changes, they're more than absolutely worth doing, and you'll just have a much better overall experience.
Yeah, and by the way, I forgot to mention that using those parameters is something that you can use along through the process of parsers creation. You can use it in the matching condition if this field equals to the other, and all those, and it can be applied also in the matching conditions, also in the status definition, and as I showed you in the field mapping. So it's really up to you, and it has like endless option here to really operate.
Yeah, good points, good points. We have one more question here. Thank you, Courtney. If I'm working for the threat hunt side and I find a test result that should only be a detection, but it only shows log, how can just changing the event to detection make submitting a parser change the alert on the Microsoft MDE system side? So when it's detected next time, it will show fully in the MDE system and not just show up in SafeBreach.
One second, I want to make sure I understand the question.
So let me rephrase the question. Restated. It sounds like if there's a simulation result in SafeBreach that's only showing logged, but that it should be showing detected in SafeBreach. So if that is the reality, then that is when a parser would be used. But a parser, the second part of the question is about changing what's on the Microsoft Defender side. So our changes in SafeBreach are not going to change anything about how it's categorized in Defender. The changes in the parsing are for when our app ingests that log from Defender. If it interprets it as logged when there was actually an alert in Defender, it's for correcting the way that our app interpreted the logs as they are. At no point do our integrations change anything in your endpoint controls. Did that answer the question? And is there a follow-up?
Not seeing a follow-up so far. Courtney, give us a shout out in the chat if you feel like we answered the question. If not, we'd be happy to follow up with you one-on-one just because I see we're really running up on time.
Oh, yes.
Okay, that answers her question. Thank you. Okay. All right. Thank you. You've been a lovely audience. I've never had such an audience who's been so engaged before and who's stuck with us for the whole webinar. Thank you so much for being here. Again, thank you again to Jonathan Shahaf for being here and presenting such an in-depth demo. And there's one thing about SafeBreach I do want to say, which is that we're very, very, very configurable. I think it's one of our big strengths as an organization. We very much help our customers find the right fit for their organization. So this is just the tip of the iceberg. We should a general demo. If you want to talk to us about specifics within your organization, please reach out. We'd be happy to get back to you as soon as possible to see how it might work within your system, on your infrastructure, and with your parameters. And that's it. Thanks again, and have a great rest of your workday.
Thank you very much, guys. Thank you for listening.
Thank you.